Okay, here are some quick video solutions to N8 and N9 on assignment 36. Okay, so starting with N8, in part A, you're asked to take the identity sine squared theta plus cos squared theta is always equal to 1, and you're asked to turn it into cosec squared minus cot squared is always equal to 1. So how do you do that? A big clue is that you're after a cot squared. So how could I get a cot squared from this? Well, cos squared over sine squared is cot squared. So in order to do that, I'm going to divide every term by sine squared. So if I do that, we get sine squared theta over sine squared theta plus cos squared theta over sine squared theta is always equal to 1 over sine squared theta. You might spot that right hand side now where the cosec squared is going to come from. So just move that down a bit and rewrite things. So sine squared over sine squared is 1 plus cos squared over sine squared, that's our cot squared theta, is always equal to, cosec squared theta. If you got this far, basically done it now, we're just going to rewrite this in the form that they required. So I'm now just going to state cosec squared theta minus cot squared theta is always equal to 1. I'm just going to write as required. Always good practice to finish like that if you're asked to show something. Okay, there we go, that's part A. So moving down, in part B, what we're asked to do is we're asked to show, I'm just going to write the question out, cosec to the 4 theta minus cot to the 4 theta is always equal to cosec squared theta plus cot squared theta. Okay, we're not solving an equation here. We're simply asked to show that this left-hand side is always equal to this right-hand side. So what we've got to do that is take one of the sides, manipulate it, and turn it into the other side. So in order to do that, you need to take one side, turn it into the other. 99% of the times these questions are written where it's easier to take the left and turn it into the right than the right into the left. So that's what I'm going to do. So I'm just going to write LHS for left-hand side and rewrite it. So cosec to the 4 theta minus cot to the 4 theta. Now I'm just looking at this and going, well, what can I do with it? Well, it actually factorizes the difference of two squares, something to spot. So if I rewrite it using that fact, I get cosec squared theta plus cot squared theta. That's quite useful, looking at what I'm trying to turn it into. Multiplied by cosec squared theta minus cot squared theta. Now, just move this down, if you look at this now and you look at your part A, that right-hand bracket you've already shown for your part A is always equal to 1. So basically I can now rewrite this as cosec squared theta plus cot squared theta times 1, and then I've done it now, I'll write it one more time, cosec squared theta plus cot squared theta. Now just formalize to finish, I'm just going to write left hand side is always equal to right hand side as required. Okay, so we've shown it. Okay, so we've shown that the left hand side is always equal to the right hand side. Moving on to part C, we are now solving an equation. Notice because it's an equal sign in there now. So what are we solving? We're solving cosec to the 4 theta minus cot to the 4 theta is equal to 2 minus cot theta. Where do we start here? Well, a big clue is what you've just done. In an exam, they probably would use the word hence for this. They would probably say hence solve, all right, which would be a really big clue that you're going to have to use something that you've already done. This left-hand side, we know from our part B, can be written as cosec squared theta plus cot squared theta. All right, so we're now going to put that equal to 2 minus cot theta. Looking to solve this. Well, at the minute, I've got cosecs and cots involved. So can I rewrite it all in terms of cosec or in terms of cot? Yes, I can, because there's an identity we should know here. All right, cosec squared can be written as 1 plus cot squared. So I'm going to rewrite this as 1 plus cot squared theta plus cot squared theta is equal to 2 minus cot theta. You might spot now, you've got a quadratic, all in terms of cot, so I'm just going to get everything on one side and get it equal to 0. So doing that, I've got 2 cot squared theta plus cot theta, take 1 is equal to 0. Got a quadratic to solve, could factorise it, could use your calculator. Alright, probably easiest by a question like this, you're just going to type it into your calculator and get your solutions. So doing that, we get cot theta is equal to 1/2, and we get cot theta is equal to -1. Now in order to solve this, alright, I'm going to want to rewrite this back in terms of tan. So cot is the reciprocal of tan, so if cot theta is 1/2, tan theta is equal to 2, and if cot theta is equal to -1, then tan theta is equal to -1. Then solutions, going from here, tan theta is equal to 2, I get theta is equal to 63.4 degrees. Now that's not in the range I want. The range that I want is, this question asks for solutions between 0 and 180, no it doesn't, it asks for solutions between 90 and 180 degrees, I believe. Alright, this isn't in the range. Remember, there are other solutions, it's an infinite amount of solutions. With tan, the easiest thing is you can just, if it's just tan theta, you can just keep adding or subtracting 180. So I could add 180 or subtract 180 to this for another solution. However, I can see that they're not going to actually be in the range that I want either. So that's actually not a solution that I'm after. This one, I get theta is equal to -45, which isn't in the range I want. However, if I add 180 to that, I get 135, which is in the range I want. Alright, so, well, that didn't come out red, that doesn't matter. Theta is equal to 135 degrees is actually the only answer for that in the range that we're asked to find those answers. So there we go. That is question N8 done. Going on to N9, part A, we're asked to solve 3 arc sine x take 3 is equal to pi. Okay, first step doing this, I'm going to get the arc sine bit on its own, so divide by 3. So arc sine x take 3 is equal to pi over 3. Now I want to do the undo the arc sine, if you like. So what's the inverse of arc sine? Well, it's sine. So sine both sides, we get x take 3. I don't know why I bothered writing those brackets there still, but anyway. You get x take 3 is equal to sine of pi over 3. So x take 3 is equal to root 3 over 2. Alright, that's what sine of pi over 3 is. And then just add the 3. So x is equal to root 3 over 2 plus 3. Okay. One more to go in part B, which you might not need this video solution now because it's the same process we're going to repeat. We've got 2 arc cos 2x take 1 is equal to pi over 2. Okay, first bit, just going to try and get arc cos on its own, so divide by 2. So arc cos, that is meant to say arc cos, right? 2x take 1 is equal to pi over 4. What's the inverse of arc cos? It's cos. So cos both sides if you like. 2x take 1 is equal to cos of pi over 4. 2x take 1 is equal to root 2 over 2. And at that point, I'm just going to come over here due to a bit of a lack of space there. Basically, you're just going to get x the subject now. I reckon that you guys could go from there from this point. So if you do that, you're going to get x is equal to root 2 plus 2 over 4. It just turns into right once you get x as subject to that. Okay, that's the video solutions for N8 and N9 for assignment 36.